Well, this week we're going to be talking about the biocultural foundations of development. The progress of human development is typically a predictable course, but within those similarities there are infinite variations in how we humans are. Almost all of us are genetically unique. We inherit biological characteristics and predispositions that are tempered by our cultures and environments. Even genetically identical twins, monozygotic twins, develop their own interests, abilities, and personalities. And this week we'll look at how biology and culture interact to produce unique human beings. Here we go. Now, as we talk about inheriting culture, we need to look at what exactly is culture anyway. And culture does consist of material and symbolic tools that are accumulated through time. They're passed down through social processes, and they provide resources for the developing child. What we mean when we say material tools is we're including not only physical objects like hammers and computers, but also observable patterns of behavior like family routines and social practices. When we talk about symbolic tools, those are more abstract. They're more related to knowledge, beliefs, and values. Symbol systems like mathematics, religious beliefs and practices, and the society's expectation of male and female sex roles are all examples. Many tools of culture are both material and symbolic. When we talk about mediation, that refers to the way people's activities are organized through the use of cultural tools. There's a debate about the ways in which a culture's material and symbolic tools mediate children's behavior and development. For example, one of the questions that comes up is, will playing violent video games lead children to behave more aggressively? We have quite a bit of evidence now that leads us to believe that the answer to that is yes. But that's an example of mediation. Okay, now let's talk about the processes of cultural inheritance. When material and symbolic tools are passed on from one generation to the next, the culture is being not only transmitted, but it's being transformed too. So social processes involved in cultural inheritance are social enhancement, where children make use of resources that happen to be available to them because of other people's activities. Also imitation, in which children learn from observing and copying the activities of others. And explicit instruction, where children are purposefully taught to use the resources of their culture. Explicit instruction makes use of symbolic communication, like for language, drawing, and music, so it's possible to inform children about objects and events that are not present in the environment. Symbolic communication also allows the expression of abstract ideas and the expression of feelings and cultural values. For example, Stephanie Carlson in her research group found that children performed better on self-controlled tasks in which they needed to pick the smaller set of candies in order to get the larger one, when the choices were marked with symbols compared to when the choices were visibly present. Now let's look at the complexity of culture. The people of a culture, in interaction with others, produce variations in the material and symbolic cultural tools that they use. And this process of change through variation is called cumulative cultural evolution. Evidence of this can be seen in developing technology, for example, in the many different methods, from messengers and letters to cell phones and email, that people have developed over the years for communicating with one another. Similar change can be seen in symbolic resources, for example, the development of scientific understanding. There's evidence that more cultural evolution occurs in larger or less isolated societies, and some aspects of culture can be lost when a group becomes isolated from outside influences, and the amount of variation in the group is lessened. Variation is also essential for biological evolution. Now let's take a look at biological inheritance. How is an individual's genetic endowment expressed in physical and psychological traits? How does genetic endowment relate to the process of evolution? Well, when we look at genes and traits, we have a subheading of heredity. Heredity is the transmission of biological characteristics from one generation to the next. The units of heredity are genes, the segments on a DNA molecule that contains instructions to guide the formation of physical and psychological traits. It's like a little map for our developing organism. An individual's genotype represents that person's exact genetic makeup. The individual's phenotype, or observable characteristics, develops as a result of the interaction between that person's inherited traits and the environment. Identical twins have identical genotypes, but even their phenotypes are not exactly alike, and they become progressively different with the accumulation of interactions with the environment. So genotype and phenotype have distinct roles in evolution. And as you're reading through this, I'd like you to just think of an example that applies to yourself. Think of a genotype that exists in your family that you know exists that may not be observable as a phenotype. Even something like shyness seems to have a genetic tendency, but every person that is carrying that genetic tendency may not turn out to be shy. So apply it to yourself, think of a good example for yourself, and that will help you to remember this section. Now, let's look at evolution's process of natural selection. According to Charles Darwin, natural selection determines which phenotypes survive. Individuals whose phenotypes are successfully adapted to their environments are more likely to survive to reproduce. Phenotypic variation is necessary for natural selection to occur. Now, this section can be a little troubling, especially to people who are pregnant. So if you're pregnant, just take this with a grain of salt, okay? We are going to talk about mutations and genetic abnormalities. Genetic diversity can occur through mutations. Mutations are a natural part of life. Sometimes we think of mutations as being, monstrous kinds of things, but there are many mutations that are not even observable or visible on the outside. Genetic diversity can occur through change or mutation or a change in the structure of a person's genetic map or DNA. There are different kinds of mutations. So mutations in the bodily cells or somatic cells will only affect the people that they're occurring in. But a mutation in a germ cell, sperm or the egg, is going to change the inherited or may change the inherited genetic information and be passed on to generations. And when you look at the information on Down syndrome, you'll see this explained a little bit more. The 23rd pair of chromosomes in normal females are both X chromosomes, and normal males have one X chromosome and one much smaller X chromosome. Whereas an ovum or an egg always has an X chromosome, a sperm can contain an X or a Y chromosome. And the 23rd chromosome determines a person's genetic sex. But other characteristics also have more complex origins. Now, here are some examples of mutations and genetic abnormalities. Genetic diversity can also occur through mutation, which is an alteration in the structure of an individual's DNA. Mutations in somatic cells, just as we said a little earlier, affect the person that they're occurring in. Mutations in the germ cells result in change or can result in changed genetic information being passed on, not only to the next generation, but over time to the gene pool. And the gene pool is the total variety of genetic information possessed by the reproducing population. But as a natural part of life, they do provide a source of variation that we need for natural selection to occur. Now, the majority of mutations are lethal, and they occur very early in pregnancy and result in miscarriage. So this is kind of the body's way of saying, this one didn't take, flushing it out. It's not a viable organism. And many times women who have an early miscarriage due to a mutation don't even realize that they're pregnant. They may just think that they're having a heavy menstrual period. So this is actually probably more common than we think, because if that occurs, a person would not be concerned about a miscarriage, they didn't know that they had one. About 3.5% of babies are born with some kind of genetic abnormality. And in your text, you'll show some common disorders that are related to genetic abnormalities, and we'll just go through a few here. But babies that are born with genetic abnormalities that are not apparent sometimes are never diagnosed. I know someone who was diagnosed with an abnormality in utero before they were born, and apparently what happened, this was a baby boy, is a piece of the X chromosome and a piece of the Y chromosome broke off and changed places. And the doctor said that if this happened at birth, that it could contribute to developmental delay in the baby. But if it was a trait that was already part of the family's genetic trait, then because the father was developmentally normal and the mother didn't have that characteristic in her blood, because when you're pregnant they take a lot of blood and they didn't see it in there, then if it was part of the genetic makeup of the family, then it probably would not be related to any kind of abnormality. And as it turned out, when the father's blood was tested, he did have that trait, and the baby was born and was completely normal. So if the mother and father had not gone through genetic counseling, they may never have realized that their children had a mutation or an abnormality in the gene. And as it turned out, it didn't have any impact in the child's life at all. So going on to some of the conditions that are more problematic, phenylketonuria is one, also called PKU. This is something that is tested for in utero usually, or if not, then it's tested soon after birth. It's an inherited metabolic disorder that results from a recessive gene. It occurs through normal genetic transmission when both parents pass the recessive allele to their child. And children with PKU have trouble metabolizing phenylalanine, which is an amino acid, and the buildup of phenylalanine in the bloodstream causes brain damage. So once this condition is identified, then you can immediately start to alter the environment of children. And to do that, for this particular condition, you have to remove from their diet foods that are high in that amino acid. And then the effects of this disorder can be greatly reduced. So when you have a baby, sometimes they will take the baby off to be bathed, and you may notice that the baby comes back with a little pinprick in the heel. That's probably because they've taken a little bit of blood and they're testing for PKU. Another condition is Down syndrome, and Down syndrome occurs not through normal genetic transmission, but through a disruption of the normal process of genetic transmission. And the affected person has an extra genetic material on chromosome 21, or in most cases, an extra copy of the chromosome. And this disorder results in mental retardation as well as a number of distinctive physical characteristics. But the severity of the disorder varies, and supportive intervention, early intervention, can improve the functioning of children who have Down syndrome. One thing that you'll find if you have genetic testing while the fetus is still in utero is that the results may show that the child will have Down syndrome, but it won't tell you the level of severity of mental retardation. So in a way, it's kind of a crapshoot, and you won't know until the child is born. And then even after the child is born, the early intervention that is done or can be done can have a tremendous impact on the severity of the condition. Half of all chromosomal abnormalities in newborns involve the X and Y chromosomes, and the most common sex-linked chromosomal abnormality is Klinefelter syndrome, where a boy has an extra X chromosome, so instead of being XY, the structure is XXY. This disorder occurs in 1 of every 500 to 1,000 males born in the United States. And the boys usually develop normally until adolescence, and then at that point they fail to develop secondary sex characteristics or characteristics of sexual maturity. They may also have speech and language problems that lead to difficulties in school. There is hormone replacement therapy that can be done, testosterone replacement therapy. They start that at about age 11 or 12, and that can have beneficial effects in the physical development and sexual functioning of men affected by this disorder, but they are still sterile. They're not fertile and won't be able to physically or biologically father a child. The parallel syndrome in females is called Turner syndrome. You'll read about that in the text. It also has a similar time of diagnosis, usually around the age when a child should be developing secondary sex characteristics, and they don't. Now, one thing that you'll be seeing that's very interesting is a film clip on intersex conditions. And this is when a child is born and has genitalia that have characteristics of male and female, or may have characteristics of female genitalia that are a little different or visually, or just there's a whole number of variations that can occur. And actually intersex is an umbrella term that refers to a lot of different specific conditions. So you'll see in that film that when that occurs, and it probably occurs a little more frequently than is reported, that advocates are now saying that it's best to hold off on any kind of surgical intervention, but to do a complete physical and medical workup, assign a sex to the baby so that when people ask you, did you have a boy or a girl, you're not just, shrugging your shoulders, you say boy or girl, and then give the child privacy while they're growing up, and also get a sense as the child is growing up to see how they feel internally. Do they feel more male? Do they have more female? And then use that as a guide for any other medical interventions. Many advocates now are saying that they're not recommending any surgical procedures. So that is an issue that's very much in discussion. And as you see the clip, I'll be interested to see what you have to say in the discussion boards, because for many people this is kind of new information. This may be one of the times when your mind starts to go, we'll see. All right. Let's talk a little bit about genotypes, phenotypes, and human behavior. There are a couple of questions that are raised. First is, what role do developing individuals play in the process of their own development? And secondly, how do the individual's cultural and social environments form and transform the landscape over the course of a lifetime? And developmentalists use the term niche construction to refer to the ways individuals actively shape and modify the environments in which they live. For example, a quiet, undemanding infant evokes different responses from adults than an infant who's very fussy and demanding. But because niche construction is a social process that proceeds through interactions with parents, siblings, playmates, and others, it's best thought of as a process of co-construction between developing individuals and the important people in their lives. Children's physical environments are also important to their development, and the term ecological inheritance refers to environmental changes or modifications that affect the development of offspring or descendants. Examples of ecological inheritance are selection of habitat, for example, migrating to a new land or relocating from a rural to an urban environment, and changes to the existing habitat, for example, building homes and schools, or conversely, depleting natural resources. Research from the ecological perspective can show how human activity affects the genotype and the phenotype of developing individuals. The idea of a co-evolution of culture and biology is a kind of a later development in the study of developmental science, and I think it's very exciting. Rudimentary forms of culture were already present during early phases of human evolution. Humans' biological evolution did not end with the appearance of culture. Instead, biology and culture have interacted with each other in this process called coevolution. James Mark Baldwin, an early developmentalist that's mentioned back in Chapter 1, He proposed that cultural factors influence the likelihood that people with particular traits will survive. And this idea is called the Baldwin effect. Individuals who have access to knowledge that enhances survival, for example, how to build shelters, prepare food, heal illness, those people are more likely to live long enough to reproduce and then pass their knowledge on to their children. And on the slides we have a couple of examples of biological and cultural interactions. One is lactose tolerance, which is common among pastoral nomadic peoples. As we generally grow up to become adults, we tend to become more and more lactose intolerant. But the amount of tolerance that we have for milk and dairy products actually has a genetic root and basis in what our forefathers and foremothers and ancestors did to make a living. If they were mostly farming and didn't have many dairy products in their diet, then you're more likely to be lactose intolerant. If you come from ancestors that are more pastoral, nomadic, and lived with their animals, they were herders, so they lived on the products of sheep and cows and so on, then you probably have more of an adaptability to be able to tolerate lactose. Sickle cell anemia is another example of the coevolution of biology and culture. It is a serious blood disorder that occurs in people whose both parents have the recessive sickle cell trait, so they inherit it from both parents. People who are heterozygous, or only one parent has the trait, actually do not suffer from the severe symptoms of the disease, and it gives them protection against malaria. So we see that the population in West Africa, where there is more malaria, we see more of a sickle cell trait there than we do in studies of African American people who were brought over through the horrific slave trade. But just within the period of a few generations, we see that there's been a reduction in the sickle cell anemia trait in people who originate from Western Africa. Well, our evolutionary forebears had lives and experiences that were different from us, in some way very similar to our own. And an understanding of our biocultural foundations helps us to illustrate how the interplay between similarity and diversity helps to ensure that our biological and cultural heritages not only are passed to successive generations, but also continue to evolve over time. Now, the structure of the central nervous system is composed of three parts: the spinal cord, the brain stem, and the cerebral cortex. The spinal cord extends down the back to below the waist. It contains the spinal nerves that carry messages between the brain and specific areas of the body. The brain stem is at the top of the spinal cord, and that controls breathing, sleeping, and elementary reactions like blinking and sucking. The cerebral cortex is divided into two hemispheres, and each one of those has 4 lobes. They're separated by deep grooves and specialized for different functions. The occipital lobes are specialized for vision, the temporal lobes for hearing and speech, the parietal lobes for spatial perception, and the frontal lobes for control and coordination of the other cortical areas, which allows for more complex forms of behavior and thought. Now, the human cortex also has large uncommitted areas, which allows the brain to change in response to the experiences that young people encounter as they develop. And that is, to use a term from a little bit earlier, to demonstrate plasticity or malleability. At birth, the spinal cord and brain stem are the most highly developed areas of the central nervous system. The cerebral cortex is relatively immature and is not well connected to the lower brain areas. As the fibers connecting the cortex with brain stem and spinal cord become myelinated, the infant's abilities expand. And we'll talk more about what happens during adolescence, but this is kind of the early picture. When we talk about the experience and development of the brain, first let's look at brain development in general, which takes place according to kind of an internal biological process. It's sort of a clock, and it is a predictable course of development, but it is also influenced by the environment. Some processes of brain development are referred to as experience expectant, and these seem to anticipate experiences that infants will encounter in any normal environment. Examples of these experiences are encountering visual light, dark borders, hearing the sounds of human language, and things like that are an expected part of the experience of being a human. Evidence for these processes is found in the exuberant synaptogenesis that occurs during several points of development, and that is just a fancy way of saying that there's a lot of growth. And that occurs during several points of development. It occurs very early, and it also occurs during adolescence as well as during other times. The synapses that are not used will die off selectively in a process called synaptic pruning, and that occurs both prenatally and then periodically until early adulthood. And now we have evidence that synaptic growth and pruning also occurs throughout life. There's evidence that it occurs for women after childbirth and nursing, and for older people as we encounter more and more experiences in life. So as we learn more about the brain, the news gets better and better for those of us who are aging, and if we're lucky, we'll all age. Although experience expectant synapses are created before they're needed, in experience-dependent brain development, synapses are generated in response to an individual's specific experience. So there's growth in anticipation of experiences, and then there's growth as the neural pathways become used. And the pathways that are used frequently get stronger and stronger. Let's take a look at the endocrine system. The endocrine system is made up of glands in various parts of the body, and these glands release chemicals called hormones into the bloodstream. The hormones affect the development and functioning of many parts of the body. So let's take a look at some of the glands that are part of the endocrine system and at the hormones that they begin to secrete during puberty. The initiation of puberty is taking place in the hypothalamus when the hormonal changes of puberty begin in the hypothalamus. Now that's a bean-sized structure that is located in the lower part of the brain. It's beneath the cortex. And the hypothalamus has a lot of effects on physiological and psychological motivation and functioning in areas like eating, drinking, and sexuality. In addition to these functions, the hypothalamus stimulates and regulates the production of hormones by other glands. To begin puberty, the hypothalamus starts to increase its production of gonadotropin-releasing hormone, or in shorthand, GnRH. And that releases in pulses at intervals of about 2 hours. The increase in GnRH starts in middle childhood. The increase in GnRH begins in middle childhood at least a year or two before even the earliest bodily changes of hormones. Let's talk a little bit about what happens during puberty. We see a growth spurt. There's physical growth, and for both girls and boys, this is an adolescent growth spurt. And you'll see in your readings a chart figure that shows the typical rate of growth in height from birth through age 19, and that includes the adolescent growth spurt. At peak height velocity, when the adolescent growth spurt is at its maximum, girls grow at about 3.5 inches per year, and boys grow at about 4.1 inches per year. But for both boys and girls, the rate of growth at peak height velocity is the highest that has been since they were 2 years old. And this is sometimes why you'll hear people say that this period of puberty and adolescence is very similar to toddlerhood. The body is expending tremendous amount of energy, and there are a lot of demands on it for growth and development. So the issue of getting enough sleep and so on is pretty much as important, if not more important, than it was at these very younger years. We see a lot of brain development during this time. We see additional synapses being developed. We see not only synapses throughout the brain, but we see that some of this development and myelination, or the covering of fatty cells on the nerve cells, happens not only on the nerve, around the nerve endings and nerve pathways, but also in the areas of the brain that are kind of border areas of the brain. So that allows not only the impulses to communicate better and in a more organized way throughout the brain structure, but different regions of the brain have the ability to communicate better with each other. Let's look a little bit about the culture and the timing of puberty. Cultures influence the timing of the initiation of puberty in different ways, and the definition of culture includes a group's technologies. Technologies include things like food production, medical care, and the age that puberty begins at is very strongly influenced by the extent to which food production provides for adequate nutrition and medical care provides for good health throughout childhood. Sometimes we think of this in terms of being a deficit of cultures outside of the U.S., but in actuality now there's quite a bit of research that's looking at the things that we eat here in the United States that are not necessarily more healthy for us. Things like additives, chemicals, and so on in our foods, and also the genetic modification of foods can have a negative effect on our nutrition. So all is not rosy in the United States necessarily. So sometimes when we see other cultures, they're actually eating a more healthful diet if they have the resources to get variety in their own the food production that they have there. Persuasive evidence for the influence of technologies on pubertal timing comes from the historical records that we have that shows a steady decrease in the average age of menarche in Western countries over the past 150 years. This kind of change in a population over time is called a secular trend. And as you'll see in your readings, there's a secular trend downward in the age of menarche that's occurred in every Western country that we have records for. Now, menarche is not a perfect indicator of the initiation of puberty. As you've seen in your readings previously, the first outward signs of puberty appear much earlier for most girls, and of course menarche doesn't apply to boys. But menarche is a pretty good indicator of when other events in the body have started to occur. So we can use that as a kind of a guide and indication that other changes are occurring. When we look around the world, we find that the average age of menarche is lowest in developed countries or industrialized countries where medical care tends to be more available, and to some extent adequacy of nutrition is more available. One thing that influences menarche is body fat, according to the data that we have so far. And very, very low body fat can contribute to a delayed menarche in girls. So girls that are either very athletic or who have been dieting to lower their body fat to very, very low levels sometimes will show a delayed menarche or first menstrual period, or no menstrual period at all.
Okay, test the clicker. Okay, so this is and puberty. So ready to go in 3, 2, 1, and
Let's take a moment and just review what puberty is exactly. You probably have heard a lot about puberty in high school classes and learned a lot about puberty through your own experiences. But just to kind of recap, puberty involves a process where there are changes in primary sex characteristics, and those are the production of the eggs in girls and sperm in guys, and the development of sex organs. Also involves changes in secondary sex characteristics. These are the more observable characteristics that people can see even though you have your clothes on. So these are other changes in physical characteristics, so growth of some body hair, changes in the body shape and size, changes in reproductive anatomy, breast, hip development in girls, and underneath the clothes there are changes in the size of the penis and the testes in boys. And in boys we also see more facial hair and a deepening of the voice in boys. The term for the first menstrual period in girls is called menarche, and the term for the first ejaculation of semen in boys is called seminarche. What we see is that there are cultural factors that influence on the physical changes that happen, and also the place that a person who's of reproductive maturity has in their society. So there's a trend that's referred to in the literature as a secular trend. And what that means is that in Western countries we see a decrease that's pretty steady in the average age of menarche. In the industrialized countries, the average age of menarche is the lowest compared to other countries. In many countries, puberty is marked by ritual. In the U.S. and other Western countries, there are less formal rituals, although we still see some cultural rituals that maybe not are attached to the actual physical change of puberty, but the general period of adolescence, coming of age rituals like quinceañeras, bar mitzvahs, bat mitzvahs, and rituals like that are associated with that change in that accompanies puberty. In other cultures, other countries, there are puberty rituals for males that often require, they're showing strength, ability to withstand pain. Sometimes piercings, tattoos, body markings are applied to boys and girls. Now, the question of genital cutting is a question that has received a lot of attention and debate. Some cultures maintain public genital foreskin cutting rituals for adolescent boys, and there are also some places that still have genital cutting for females. Now, the term circumcision is used both for males and females. What we see increasingly among people who are advocating for boys and girls to remain intact in their genital area, unless there's a medical problem to recommend otherwise, is that instead of referring to the procedure of cutting as circumcision, especially in girls, the term that's more frequently used now is genital female mutilation. And there's a growing movement against female mutilation, which can have devastating effects, not the movement, but the surgery, the operation can have devastating effects on girls. It is aimed at cutting off the clitoris, or one of the main centers of sexual pleasure. It can cause a lot of infection. It can cause significant problems in elimination, childbirth, and just getting around. So especially among the women who live in cultures and countries where that practice still occurs, we see a growing movement and people actually asking for political asylum to be protected from genital female mutilation. The cutting that's involved for males usually involves removal of the foreskin on the penis, which, you know, in a healthy boy, many pediatricians are saying there's no need to remove the foreskin. But this is a debate, and the pendulum swings back and forth, so to speak, on this question. So you'll see in some of your additional readings some of the debates that take place around this, around these questions. When we're talking about infant genital cutting for males, that is what is more common in the U.S., in Western cultures. In other cultures, some of that takes place as the boy approaches reproductive maturity. So it occurs more when they're adolescents. So see what you think about this. Every parent that has a boy child in the U.S. makes a decision about whether or not to have their child genitally cut or circumcised. So as an informed consumer, it's good to know what the pros and cons are if that's a choice that you're facing for your son. Let's look a little bit at aspects of maturation. Sometimes we see people maturing a little bit earlier than what's expected, and sometimes we see late maturation. For girls in the West, early maturation is associated with some negative effects. Sometimes a girl will have to face challenges that she is not really prepared emotionally to face if she matures early. She may appear to be an older girl, so she may be attracting, romantic approaches from people, and she may really be too young to navigate that. We don't really see early maturation noted in other regions of the world. We don't see similar effects noted for late maturation, although in the West this can also have a temporary negative body image if a girl or a boy seems to be much younger than they really are in terms of age. So looking at boys in particular, if a boy matures early in the West, that tends to be associated more with positive self-images. Although if they seem older than they are, that can also mean that they're also involved in activities that are more like adult activities, and they may not be emotionally equipped to handle those. So it does pose some risk factors. Now, late maturation does pose some risk factors for both. Mostly it's because of how a person is viewed in the culture. If they look too babyish in relation to the way other children or young people, adolescents of their age look, they can be teased, or they can, feel that there's something wrong with them. What's interesting is that when we look at cultures where schooling either doesn't exist or there's no age-graded schooling, that some of these factors seem to diminish, seem to disappear almost. But, if you're in the 5th grade, you have a pretty good idea of how most kids look in the 5th grade. If there's just one school environment with kids from a lot of different ages and grade levels, then those differences just don't seem to be as noted. But we certainly need some more research on this area. When we look at the makeup of human beings, we see categories that are either part of the genetic makeup or an expression of the genetic makeup. So the actual biological map that we have is referred to as a genotype, and the outward expression of our genetic makeup is called a phenotype. And these things interact with culture and also contribute to human behavior. Niche construction is a term that's used looking at the biological and cultural interactions of human development. It refers to the ways that individuals actively create their own environments together with their parents and their family, their playmates, siblings, to come to be the way they are. And this is referred in the literature to a co-construction of development. We also have an ecological inheritance, or an inheritance from the various contexts or environments that we live in, and this also affects the development of our offspring or descendants. So looking at biological development as it relates to the environment, we kind of see that there's a new type of genotype that results in or develops into environment effects. The genetics and the environment contribute to development, but it's very hard to tease out the two when we look at the research, because genes influence the kind of environment that is experienced. Now, this is a rather new way of talking about this whole phenomena, so there's not general agreement about this particular theory, There is debate around it. The author of the textbook, Arnett, refers to it often, so it seems to be a theory that really speaks to him. But just keep in mind that other people have other opinions about this, and this is just one particular theory that the author of the textbook feels is important. So we will include that in our discussion. Looking more at the theory of genotype as it morphs into environmental effects, there are different kinds of genotypes that are discussed in this theory. One is a passive genotype that results in environmental effects, and that refers to biological families providing both genes and the environment for their children. Another type is called the evocative genotype that results in environment effects. And those are inherited characteristics that evoke responses from others in the environment. So this is an interactional aspect of a genotype. And then another type is an active genotype resulting in environment effects, where people actually seek out environments that correspond to their genotypic characteristics. So there are a lot of possibilities when we look at how this theory actually may play out in development. Being an adolescent can pose some risks. We see that accident and illness account for many fatalities and injuries. One thing that happens with many adolescents is that there's more access to opportunities to kind of get hurt or get into trouble, and those opportunities may be way ahead of the actual experience that a young person has and the capacity to navigate some of these new experiences to make some good decisions or choices. So sometimes we see young people taking risks that maybe when they're a little older they wouldn't take, but they have a physical capacity and the opportunity to engage in some of these behaviors, whether they're in sports or in dating or any number of experiences that come their way. One big risk that we see for young people is obesity. I remember my son saying when he was approaching adolescence that his generation, this is something he learned in health class, his generation is expected to have a lower life expectancy than my generation, and this is really the first time that we know of that this has occurred. And why is that? Even though we have more medical knowledge and so on, the thinking is that young people are subject to being obese in part because of less activity, as young people spend more and more time in front of screens and not going out and running around the way we used to in younger generations. Also on the wide availability of fast foods that are not particularly healthy for us. And newer research is also focusing on the bad effects of food that's very highly processed, that actually has ingredients that are not food, that have a lot of toxic additives or are genetically modified. And this is changing the way our bodies process these substances. So this is one of the opinions, one of the thoughts about what is contributing to the poor health and obesity and other health problems of young people.